Welcome everyone. Today I'm going to do just a quickie about one of the fundamental differences between Maven and Gradle. So often when we ask people about the differences, they would mention that Gradle is more flexible or that Maven uses POM XML, so XML configuration, and Gradle uses Groovy or Kotlin scripts for configuration. And they would argue on that basically. But to me, this is not the most important thing to understand. One of the most fundamental differences is what I'm going to explain in this session. So let's take a look at my test project. What we can see is that we have a simple application, and if we look at the sources, it basically prints out a hello world. And we have both a pom.xml file for Maven and a build.gradle file for Gradle. So let's take a look at the differences between the tools. So the pom.xml file defines two things. So first, the target that we want to use for the sources, so 8 in this case, and the exec Maven plugin, which is going to be bound to the verify phase and basically runs our application, right? So if I do Maven wrapper, please verify, then it does what we expect. It is going to compile everything and run our application. Okay, let's do the same for Gradle now. So the Gradle build script just says I'm using an application, uses Java 8, and then we have this main class. And in Gradle, I would do Gradle run, but I'm going to add a flag there so that you can see all the tasks which are going to be executed like Maven. Otherwise, it would be terse. And we can see it compiled the Java, it processed the resources and say hello world. But what we can see is that there's already a difference. Like when we execute the application, it didn't have to generate a jar because it knows that it doesn't have to. Like the classes are enough compared to Maven, which wanted to run the tests and package the jar just to do that. That's one of the differences, but not the one I want to talk about today, because this one is just an optimization. But for Gradle, there is something much more interesting that we're going to see right now. So let's take a look at the Java version of our classes. So I'm going to do this command line, which is going to output the major version 52, which corresponds to Java 8. If we do the same for Gradle, the build directory is in build, not target. And then we're going to, Java P, grep the major version, and it's again 52. So both will actually compiled using Java 8. So now I'm going to make a change to the panda.xml file. And we're upgrading our project. Now everybody uses 17, so let's migrate to Java 17. And I'm going to do mw verify. Okay, so Maven compiled, then packaged our jar and executed the task, and then it says hello world. Perfect. All right, but let's take a look at this class file now. So Java P and target application and grep major. Oops. What we can see is that actually it's still Java 8. So despite the fact that we changed our configuration to say now you should use 17, it did not recompile everything. Actually, Maven is worse than that. It told you there's nothing to compile, all classes are up to date. That is a lie. It had to recompile because we changed something fundamental, which changed the Java version class, so sources and class version, but it did not recompile. To fix that, you have to do Maven clean verify, and that's the reason why everybody in the Maven world always has to do clean, because otherwise you get unreliable results, because the stale files that you can have in your target directory will influence the rest of the execution of the build. So any mojo can mess up with whatever is written in those classes directories and completely break your application. And that is the main reason why you have often differences between local builds and CI builds, because CI builds would be clean builds versus local builds, which would use whatever is stale on your laptop, including your .m2 directory. Let's take a look at what Gradle does now. So in Gradle, I'm going to modify the build.gradle file and use 17. And then I'm going to do Gradle run. Okay, hello world. So now let's take a look at the Java version for Gradle. So build grep major. And what we can see is that Gradle actually did that correctly. What it did is recompiling the class. And that is the fundamental difference between the two tools. The first one doesn't know anything about the inputs of the task. If you look at the sources of those different Maven plugins, you would often figure out that some things are stringly typed, not even a file or whatever, so it doesn't even know what kind of data it is manipulating. That is not the case for Gradle. In Gradle, every task knows exactly the inputs and outputs, and it is able to optimize the execution, and then it is also able to know precisely if it has to do something, because if no configuration changed, then it has to do nothing. But if the source changed or the configuration of the Java compile task changed, which is what we have done right now, then it has to re-execute some tasks, but not all of them. So this is a very, very important difference between the two tools. And that is all I had to explain today. So thank you for listening and talk to you later.